In this class, let us see Lagrange's mean value theorem. Don't pronounce it as Lagrange's mean value theorem. It's Lagrange's mean value theorem. The theorem states that if f is a function defined on the closed interval AB and it is a real valued, and that is such that f is continuous on the closed interval AB, f is differentiable on the open interval AB. Okay, only two conditions. Be careful here. We are not writing the third condition. It should not wrongly mean to use that the third condition is not satisfied. We are not checking the condition actually. Okay, is it clear? Third condition, we are not checked it. Maybe f of a is equal to f of b, or it may be f of a is not equal to f of b. Both the cases we are allowing. Means we are least bothered about the functional values at the endpoints. With these two things, we conclude there exists C in the open interval AB such that f dash of C is equal to f of B minus f of A divided by B minus A. What is this A and B? Endpoints of the interval. A and B are endpoints of the interval. Okay. Yes. Which is smaller and which is bigger? Which will be smaller and which will be bigger in the interval AB?
A is smaller.
Very good. A is smaller, B is bigger. Don't write the closed interval 5 comma 1 and say that what real number will come. You have to write the interval 1 comma 5 only. You cannot write the interval 5 comma 1. That case is not allowing. That is not allowed. Okay, back to the point. The function which we have taken, assume that it additionally satisfies third condition. That means what is the third condition? I already told you f of a may be equal to f of b, or f of a not equal to f of b. Both the cases we are allowing, isn't it? Okay, suppose f of a is equal to f of b ಆದ್ರೆ ಏನಾಗುತ್ತೆ? ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಏನ್ ಬರುತ್ತೆ? ಈ ವ್ಯಾಲ್ಯೂ ನೋಡಿ, ನ್ಯೂಮರೇಟರ್ ವ್ಯಾಲ್ಯೂ f of a is equal to f of b ಅಂತ ತಗೊಂಡ್ರೆ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಏನ್ ಬರುತ್ತೆ?
0.
Very good, very good. 0. 0 divided by anything. That means b minus a, one value is there. 0 by that value will gives you the answer is 0. That means f dash of c is 0. Is it clear? The function which we have taken, assume that it also additionally satisfies third condition. That third condition means f of a is equal to f of b. Suppose making equal to 0 here. It is agreeing with the established fact of the Rolle's theorem, isn't it? With that one we already learned. There is no problem. But f of a is not equal to f of b. See here, f of a is not equal to f of b. Then what happens? F of a is not equal to f of b. F of a is not equal to f of b, it will be some number here, isn't it? In the numerator, it will be some number here, not equal to 0. And this denominator, whatever it may be, after adding some number, fraction will come, isn't it? Fraction will come. That will be the value of f dash of c. So this is more powerful than Rolle's theorem. This theorem is more powerful than Rolle's theorem because of b, it is able to tell some value for f dash of c, isn't it? So that is why we call this theorem as the first mean value theorem of differential calculus. First mean value theorem means first we learned Rolle's theorem. So that is the first. It is not like that. First mean value theorem doesn't mean the first we studied Rolle's theorem. So that this is the first mean value theorem. Sometimes in the examination they asked like this: state and prove first mean value theorem of differential calculus. First mean value theorem. Keep in mind, it is Lagrange mean value theorem. Okay. Here Rolle's theorem, Lagrange theorem, and Cauchy's mean value theorems. These are all the mean value theorems. Is it clear? Because they talk about C value, which is in between A and B. Because of the existence of C, which is in between A and B, they are giving the guarantee about the existence of mean values, and hence it is called mean value theorem. Is it clear? Okay. Now let us see the proof of this theorem. Here we accept the function is satisfying two conditions. Two condition means continuity and differentiability. Okay. I did not say function is satisfying only two conditions. Means what third condition is failed? No, I didn't say. Let us accept that the function is satisfying only two conditions, that is continuity and differentiability. So we have Rolle's theorem at our hand. Let's assume f is a function defined on the closed interval AB, which is a real valued, be such that f is continuous on the closed interval AB, f is differentiable on the open interval AB. Now we are ready with two conditions, that is continuity and differentiability. Rolle's theorem is applicable only with three conditions are satisfying, isn't it? Then we are making small mathematical adjustment. We will try to build up a new function which satisfies all the three conditions by making the help of the function f. Okay, I think you are following. See here, f is satisfying only two conditions. F is satisfying two conditions. Rolle's theorem cannot be applied. So we are trying to build up a new function with the help of this function f, such that this new function satisfying all the Rolle's theorem. How do you do it mathematically? How do you do it mathematically? You see, define. We will not say develop, build, all these things. Mathematically, how we write it? It define a new function pi in the same domain AB or same interval AB, and it is real valued. By a rule to this function f of x, I am adding some kx. I am adding some kx. Suppose this f of x is sin x. I will add 2x, or then it becomes sin x plus 2x, or sin x plus 3x, or sin x plus 10x. In general, sin x plus kx. In general, here f of x is a function. It is continuous. I am adding one polynomial, first degree polynomial. First degree polynomial. As you all know that polynomial functions are continuous and differentiable everywhere, isn't it? Then in general, kx, where k is some real number. You will get a question in mind, how much is the k value? We can find infinite number of k values, isn't it? Which should be there. Then we are making clear, define a function pi by a rule where k is a real number. When I say k is real number, again freedom is there, but I will say such that this new function by satisfying the third condition of the Rolle's theorem. What is the third condition of the Rolle's theorem? If f is continuous, f is differentiable, f of a is equal to f of b. Third condition, remember. Okay. So how k should be selected? This k should be selected in such a way that it satisfies the third condition of Rolle's theorem, that is pi of a is equal to pi of b. Pi of a is equal to pi of b. What is this pi of x? What is this phi of x? Phi of x is nothing but f of x plus kx. So it is made using the function f, isn't it? It is made using the function f. So pi of x is nothing but f of x plus kx. Just attaching some kx. So either 2x or 3x or 4x, like that. But what should be the k value? K should be selected in such a way that pi of A is equal to pi of B. Is it clear? Okay. Next immediate concept comes to your mind is what is the K value? First settle the K value. So now how much should be K values should be selected? Now pi of A must match with pi of B. What is the function pi of X? Pi of X and rest daily. F of X plus Kx, isn't it? It implies here pi of A means wherever X is there, substitute X is equal to A, then you will get pi of A. Pi of A is F of A plus K of A, Ka. F of A plus Ka. Next, pi of B. Pi of B means F of B plus Kb. Is it clear? Here F of A is there. Okay. Here in the left hand side, Ka is there. Shift this Kb to the LHS. It becomes minus K into B. This is equal to, in the RHS, F of A as it is. Sorry, F of B as it is. Shift this to the RHS. It becomes F of A. Here take K common or minus K. Here it becomes K, B minus A. This is equal to F of B minus F of A. Is it clear? Therefore, K is equal to, see here, K is equal to minus of F of B minus F of A divided by B minus A. We got K value. Is it clear? We got K value. If K is this much selected, is the K value actually depending upon F or not? If K value depending upon F or not? It depending upon F, see here, F of B minus F of A, like that. Yes, it is depending upon the function F. So now, if you take this much of K value and prepare the function pi of X is equal to F of X plus. Is it audible? Pi of X is equal to F of X plus Kx. Will that pi satisfies pi of A is equal to pi of V? Of course, yes. How is the function pi? How is the function pi now? It is very clear that pi of X satisfying pi of A is equal to pi of B. The third condition of Rolle's theorem is okay. What should be the, what about the first two? What about the first two? Continuity and differentiability. Now let us talk about the first two. See here, F of X is continuous. Kx is just a polynomial of first degree. So K is just a real number. So addition of two continuous function is again continuous. So pi of X is continuous on the closed interval AB. Pi of X is continuous on the, because ಯಾಕೆಂದ್ರೆ F of X ಅನ್ನೋದು ಒಂದು ಪಾಲಿನಾಮಿಯಲ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರೇನೆ. F ಅನ್ನೋದು ಕಂಟಿನ್ಯೂಸ್ ಅಂತ, Kx ಅನ್ನೋದು ಒಂದು ಪಾಲಿನಾಮಿಯಲ್. ಅಡಿಷನ್ ಆಫ್ ಟೂ ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್ ಮತ್ತೆ ನಿಮಗೆ ಕಂಟಿನ್ಯೂಸ್ ಫಂಕ್ಷನ್ ಬರುತ್ತೆ. Therefore pi of X is continuous on the closed interval AB. Similarly, F of X is differentiable, and as you all know that here Kx is polynomial, F is differentiable, Kx is differentiable. A polynomial function is continuous and differentiable everywhere in the real line. Okay. Therefore, addition of two differentiable function is again differentiable. So pi is differentiable on the open interval AB. Pi is continuous on the closed interval AB. Okay. Is it clear? And what is the third condition? Third condition is pi of A is equal to pi of B. From all this discussion, what you will say now? Pi satisfying first condition of the Rolle's theorem. second condition of the Rolle's theorem, that is differentiability, and pi satisfying third condition also, pi of A is equal to pi of P. Therefore, pi satisfy all the conditions of Rolle's theorem. When it satisfies all the conditions of Rolle's theorem on the same domain AB, what is the conclusion given by the Rolle's theorem? Therefore, there exists a number C in the interval AB such that
F dash
ಬೇಗ
C is
ಹೇಳ್ಬೇಕು.
equal to 0.
You are still in F. I am talking about pi. You are still in F,
Pi dash.
not F.
Then
Very
what,
good. Pi dash of
Pi dash
x is equal to,
x
very
is
good.
equal
Pi
to
dash
0.
of x is equal to 0. Pi dash of x is equal to 0, not F. We are talking about the new function pi. Pi satisfying continuity, differentiability, third condition also satisfied. Next, according to the Rolle's theorem, if any function satisfying these three conditions means there is a point C lies in the interval AB satisfying the condition pi dash of x is equal to 0. Is it clear? Pi dash of x is 0. See here. ಅದನ್ನೇ ಬರ್ದಿರಂತದ್ದು ಸುಮ್ಮನೆ ನೋಡ್ಕೊಳ್ಳಿ. ಸಿನ್ಸ್ ಎಫ್ ಇಸ್ ಕಂಟಿನ್ಯೂಸ್ ಆನ್ ದಿ ದೆನ್ ಪೈ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಕಂಟಿನ್ಯೂಸ್. ಎಫ್ ಇಸ್ ಡಿಫರೆನ್ಷಿಯಬಲ್, ಪೈ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಡಿಫರೆನ್ಷಿಯಬಲ್. ಥರ್ಡ್ ಕಂಡೀಷನ್ ಇಸ್ ಪೈ ಆಫ್ ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು ಪೈ ಆಫ್ ಪಿ ಬೈ ಡೆಫಿನೇಷನ್. Pi of x satisfies all the conditions of Rolle's theorem. There exists some C such satisfying this condition. Pi dash of C is equal to 0. Pi dash of x means pi dash of C is equal to 0. Okay. Since pi of x is equal to f of x plus kx, differentiate this one. Pi of x. Pi of x again differentiation no, pi dash of x. F of x again differentiation no, f dash of x. Kx again differentiation no, k is constant, real number. K into x differentiation is k. That's all. ನಮಗೆ ಬೇಕಾಗಿರೋದೇನು? ಪೈ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ ವ್ಯಾಲ್ಯೂ ಬೇಕು. ಪೈ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ ವ್ಯಾಲ್ಯೂ ಯಾವ ತರ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ತೀರಾ? ಪೈ ಡ್ಯಾಶ್ ಆಫ್ ಎಕ್ಸ್ ಗೊತ್ತಿದೆ, ಅದೇ ತರ ಪೈ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ. ವೇರ್ ಎವರ್ ಎಕ್ಸ್ ಇಸ್ ದೇರ್, ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ x is equal to c. That's all. Therefore, this one is f dash of c plus k. F dash of c plus k, equate that number to 0. It implies f dash of c is equal to minus k. It implies f dash of k is equal to minus k. What is our k value? See here. This is our k. Substitute this k value here. Substitute this k value here. K is minus, it becomes plus f of b minus f of a divided by b minus a. This completes the proof of Lagrange mean value theorem. State and prove Lagrange mean value theorem, or state and prove first mean value theorem of differential calculus andre ನೀವು ಇಲ್ಲಿ ತನಕ ಬರೀಬೇಕು. Okay, f dash of c is equal to f of b minus f of a, that's divided by b minus a. If you have any doubts regarding to this one, please, without hesitation, please ask me. No doubt? Okay. Now, let's see the geometrical interpretation of Lagrange mean value theorem. We have already seen Rolle's theorem, isn't it? Geometrical interpretation of Rolle's theorem. Here we discuss geometrical interpretation of Lagrange mean value theorem. You have the curve y is equal to f of x. Y is equal to f of x is the curve, and it's ranging from ACB. See here, ACB. So ACB is the curve, and curve is nothing but f of x. The other thing that has been A and B endpoints of the curve that we are taking into consideration, the coordinates of A. The coordinates of A is nothing but, see here, A comma f of A. The coordinates of A is A comma f of A. And coordinates of B. Coordinates of B means here B comma f of B. And also it has given to us A and B joining by the chord also. So see here, this is the chord AB. AB is the chord. AB makes an angle alpha with the x-axis. Okay, whatever it may be. See here, slope of the chord AB is equal to slope of the tangent at this point. Slope of the tangent at this point means there exists a point on the curve such that this tangent line is parallel to the chord joining the endpoints of the curve. Is it clear? In the given graph, see here, wait a minute. In the given graph, the curve y is equal to f of x is continuous from x is equal to a to x is equal to b and differentiable within the open interval a b. And according to the Lagrange mean value theorem, for any function that is continuous on the closed interval a b and differentiable on the open interval a b, then there exists some value, then there exists a some c value in the interval a b, in the interval a b, such that secant or chord, that secant or chord joining the endpoints in the interval a b is parallel to the tangent, at c. This is what which you have to be in your mind. Okay, next, in other words, it means there exists a point on the curve c such that tangent line is parallel to the chord joining the endpoints of the curve. Okay. Yes. In other words, slope of the tangent at c and the slope of the chord AB are same. Also, slope of the chord ಹೆಂಗ್ ಬರ್ಕೊಳ್ತೀರಾ, slope of the chord AB, ಇದು chord, ಇದೊಂದು ಕರ್ವ್ ಇದೆ ಅಂತಂದ್ರೆ chord ಅಂದ್ರೆ ಈ ರೀತಿಲಿ ಇಲ್ಲಿ ಪಾಯಿಂಟ್ A and this point B and slope of the tangent is ಇದು A ಅಂದ್ರೆ coordinates ಹೇಳಿದೀನಿ, ಏನಂತ ಹೇಳಿದೆ, A, f of A and B the coordinates B, f of B. It follows that f of B minus f of A divided by B minus A is equal to f dash of C. Is it clear? Is there any doubt? Is there any doubt? Okay, no problem. Next. Now let us see the problems. Very first one, verify Lagrange mean value theorem for the function f of x is equal to x square in the domain 0 to 2. Given here, the given f is a function defined in the interval 0 to 2, which is a real valued, defined by the function f of x is equal to x square. As I told you, all polynomial functions are continuous and differentiable on the real line. Since f of x is a polynomial, we can easily say that f is continuous on this interval 0, 2, f is differentiable on the domain 0, in the open interval 0, 2. Now, what is that we are going to do? We need to check whether really C is available in between 0 and 2, such that f dash of C is equal to f of 2 minus f of 0 divided by 2 minus 0. Since f of x is x square, we get f dash of x is differentiation of x square is by bidbeko. X square is a function, no?
2x.
2x. Differentiation of x square is 2x. Actually, where is the technical difficulty in some more problems? You will see in the textbook. Suppose the value of the function is, suppose here they given only x square. So ಯಾವಾಗಲೂ ಪಾಲಿನಾಮಿಯಲ್ ಮಾಡ್ತೀರಾ, ಪಾಲಿನಾಮಿಯಲ್ ಮಾಡ್ಬಿಟ್ಟು ಅದು ಕಂಟಿನ್ಯೂಸ್ ಡಿಫರೆನ್ಷಿಯಬಲ್ ಅಂತ ಹೇಳ್ತೀರಾ ಅಂತಲ್ಲ. ಕೆಲವು ಸತಿ ಏನಾಗುತ್ತೆ, ಸಪೋಸ್ ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿ ಫಂಕ್ಷನ್ ಈಸ್ sin x plus e power x ಅಂತ ಇತ್ತು ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ, ಕೊಟ್ಟಿರಂತ ಫಂಕ್ಷನ್. Then you have to write some more theory. Sin x is continuous, e power x is continuous, continuous function, continuous plus continuous is again continuous. Therefore, f of x plus e power x is continuous. Like that, you have to manage the show. Okay, sin x plus e power x. Then you have separately mentioned about and add up. Separately mention about them and add up. If you are unable to treat them, then you have to go for the higher level. What is the higher level? You have to check the continuity at all points by calculating the limits. ಅದನ್ನೆಲ್ಲ ಮಾಡಿದ್ವಲ್ಲ ಫಂಕ್ಷನ್ ವ್ಯಾಲ್ಯೂ. ಫಸ್ಟ್ ಚೆಕ್ ಇಟ್ ಅಟ್ ದಿ ಜನರಲ್ ಪಾಯಿಂಟ್, ಯಾವುದೋ ಒಂದು ಜನರಲ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಇಫ್ ಯು ಚೆಕ್ ಇಟ್ ಅಟ್ ದಿ ಜನರಲ್ ಪಾಯಿಂಟ್ ಅಂಡ್ ಯು ಕನ್ಕ್ಲೂಡ್ ಅಟ್ ಎವ್ರಿ ಪಾಯಿಂಟ್, then you have to check it at the end points. End point means right continuity at A and left continuity at B. That is the way. Okay, but most of the time they give simple problems, simple functions. Either they are sin x or cos x or a polynomial or combination of logarithmic function, exponential function, trigonometric functions like that. But you have to deal carefully. Now, considering to this case, here we have f dash of c is equal to 2c. Differentiate ಮಾಡಿ. f dash of x is 2x ಅಂತಂದ್ರೆ f dash of c ಅಂತಂದ್ರೆ 2c. That's all. Substitute. f of 2 ಅಂದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ ಇಲ್ಲಿ? f of 2 is 2 square, that is 4. f of 0 ಅಂದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ? f of 0 very good. f of 0 is 0 only. Next, substitute all these values here. Okay, it is 4 minus 0 divided by 2 minus 0 is 2. Okay, here 2c is equal to 2. Here 2 gets cancelled, c is equal to 1. Is this c lies in the interval 0 to or not? 0 to 2 or not? c value 1 ಬಂದಿದೆ. ಈ 1 ಅನ್ನೋದು 0 ಮತ್ತೆ 2 ಒಳಗಿದೆಯೋ ಇಲ್ವೋ ಅಂತ ಕೇಳ್ತಾ ಇದ್ದೀನಿ. I am asking whether this c is this c here in the real line, this one is 1, this one is 2, and this one is 3, like that. Here this one is 0. Here ನಮಗೆ ಬಂದಿರೋ ರೂಟ್ c, ಅದ್ರ ವ್ಯಾಲ್ಯೂ 1. ಈ 1 ಅನ್ನೋದು 0 ಮತ್ತೆ 2 ಅಲ್ಲಿ ಇದೆ, in the interval 0 and 2. Thus Lagrange mean value theorem is verified. Is it clear? Is there any doubt? Okay, next, move on to the next problem. Yes, verify Lagrange mean value theorem for the function f of x is equal to e power x in the domain in the interval 0 to 0, 1. Okay, all see here, as the exponent f of x is equal to e power x is the exponential function. It is continuous in the interval 0 to 1 and it is differentiable. See here also, differentiation of f dash of x, ಇಲ್ಲಿ e power x ಅನ್ನೋದು ಒಂದು ಫಂಕ್ಷನ್. ಇದೊಂಥರ ಕಲ್ಲು ಬಂಡೆ ಇದ್ದಂಗೆ, ನೀವು ಎಷ್ಟು ಸತಿ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿ, ಎಷ್ಟು ಸತಿ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿ, ಅದ್ರ ಏನು ಇದು ಶೇಕ್ ಆಗಲ್ಲ. ಅದು ನೋಡಿ, ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ f dash of x e power x ಮಾತ್ರ ಬರುತ್ತೆ. ಅಂದ್ರೆ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಆಗ್ತಾ ಇದೆ ಇಲ್ಲಿ. f dash of x exists, differentiable in the interval 0 and 1. It is differentiable in this interval. ಯಾವುದೇ ಒಂದು ಫಂಕ್ಷನ್ ಎರಡು ಕಂಡೀಷನ್. ಫಸ್ಟ್ ಕಂಡೀಷನ್ ಕಂಟಿನ್ಯೂಟಿ, ಓಕೆ, ಕಂಟಿನ್ಯೂಸ್ ಆಗಿದೆ. ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್ ಯಾವುದು? ಡಿಫರೆನ್ಷಿಯಬಲ್. ಓಕೆ, ಡಿಫರೆನ್ಷಿಯಬಲ್ ಆಗಿದೆ ಅಂತಂದ್ರೆ ಅಕಾರ್ಡಿಂಗ್ ಟು Lagrange mean value theorem, there must exist at least one point c in the interval 0 to 1 satisfying this condition. What is that condition? f dash of c is equal to f of 1 minus f of 0 divided by 1 minus 1. ಇಲ್ಲಿ f of 0 ಅಂದ್ರೆ ಎಷ್ಟು? ಇಲ್ಲಿ f of x is e power x, f of 0 is e power 0, e power 0 value is 1. Again, f of 1 value is e power 1 value is e only. That means f of 1 is e and f of 0 is 1. That's divided by 1 minus 0. F dash of c is e power c. F of 1 is e and f of 0 is 1, and substitute all these values. Okay, what is the next step? Here e power c is equal to e minus 1 anta bandide, taking log on both sides. Our intention is to calculate the value of c, isn't it? E power c is equal to log of e minus 1. Okay, by laws of logarithm, we know that log m to the power n can be written as n into log m. Similarly, in the same fashion, we can write this one as c into log e. This is equal to log of e minus 1. If anything is not given means ಇಲ್ಲಿ log e ಇದೆ, ಬೇಸ್ ಏನು ಇಲ್ಲ ಅಂತಂದ್ರೆ it is understood of base e ಅಂತ. log e of base e ಅಂತಂದ್ರೆ ಏನು? ಇದ್ರ ವ್ಯಾಲ್ಯೂ 1. Therefore c is equal to log of e minus 1. ನೀವು ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಬೇಕಾದ್ರೆ ಚೆಕ್ ಮಾಡಿ, log of e minus 1 ವ್ಯಾಲ್ಯೂ you will get 0.5. ಈ 0.5 ಅನ್ನೋದು 0 and 1 ಒಳಗೆ ಇದೆಯೋ ಇಲ್ವೋ? Yes, 0.5 lies in the interval 0 to 1. Thus Lagrange mean value theorem is verified. Is there any doubt? No. Right. Move on to the next problem. Verify Lagrange mean value theorem for the function x minus 1, x minus 2 in this interval 0 to 0.5. 1 by 2 under 0.5. Okay. As I already told you, every polynomial function is continuous and differentiable everywhere, isn't it? Therefore, this function is continuous function and this function is differentiable. F of x is continuous in the closed interval 0 to half. F of x is differentiable on the ಓಪನ್ ಇಂಟರ್ವಲ್ 0 to half ಅಂತ ಎರಡು ಲೈನ್ ಅಲ್ಲಿ ಬರೆದ್ಬಿಡಿ ಅಷ್ಟೇ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇದನ್ನ ಫಸ್ಟ್ ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡಿ, ಎಕ್ಸ್ ಇಂಟು ಎಕ್ಸ್ ಮೈನಸ್ ಒನ್ ಎಕ್ಸ್ ಮೈನಸ್ ಟು ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಬರುತ್ತೆ. ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡಿ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಎಕ್ಸ್ ನಿಮಗೆ 3x² minus 6x plus 2 ಬರುತ್ತೆ. hence f is differentiable in this interval. Next point is ಎಲ್ಲ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, find out the value of f of half, f of 0.5. that means you will get this one is 3/8, f of 0 is 0 and f dash of c is this one. ಫಸ್ಟ್ ಇದು ಎಕ್ಸ್ಪ್ಯಾಂಡ್ ಮಾಡಿ ಆಮೇಲೆ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿರೋಂಥದ್ದು ಅದು ನೀವು ಮಾಡ್ಕೊಳ್ಬೇಕು. ಓಕೆ, 3x² minus 6x plus 2 ಬಂದಿದೆ. ನಿಮಗೆ ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ ಬೇಕಂದ್ರೆ ವೇರ್ ಎವರ್ ಎಕ್ಸ್ ಇಸ್ ದೇರ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ x is equal to c, then you will get f dash of c. therefore this one is 3c² minus 6c plus 2. okay, substitute all these values. okay, here 3/8. okay, you will get 3/4 and simplifying this one you will get one quadratic equation, that is 12c² minus 24c plus 5 is equal to 0. ನಿಮಗೆ ಗೊತ್ತಿದೆ, 1ನೇ ಕ್ಲಾಸ್ 2ನೇ ಕ್ಲಾಸ್ ಎಲ್ಲ ಓದಿರ ಕ್ವಾಡ್ರಾಟಿಕ್ ಈಕ್ವೇಷನ್ ಸಾಲ್ವ್ ಮಾಡೋದು ಹೆಂಗೆ ಅಂತ. x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. ಇದನ್ನೆಲ್ಲ ನೋಡ್ಕೊಂಡು ಅದನ್ನ ಮಾಡ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ a ಜಾಗದಲ್ಲಿ 12 ಇದೆ, b ಜಾಗದಲ್ಲಿ 24 ಇದೆ, c ಜಾಗದಲ್ಲಿ 5 ಇದೆ. ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಅದನ್ನ. ದೆನ್ ಯು ವಿಲ್ ಗೆಟ್, ನಿಮಗೆ ಎರಡು ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ ಇಲ್ಲಿ. 1.7 ಅಂತ ಒಂದು ಸಿಗುತ್ತೆ, 0.2 ಅಂತ ಒಂದು ಪಾಯಿಂಟ್ ಸಿಗುತ್ತೆ. ಆಕ್ಚುಲಿ 1.7 ಈಸ್ ನಾಟ್ ಇನ್ ದಿ ಇಂಟರ್ವಲ್ 0 to half, isn't it? 0 to 0.5, half ಅಂದ್ರೆ 0 to 0.5. 1.7 ಅನ್ನೋದು ಈ ಒಂದು ಇಂಟರ್ವಲ್ ಅಲ್ಲಿ ಇಲ್ಲ, ಬಟ್ 0.2 is there in this interval. ಎಸ್, ಯಾವ್ದಾದ್ರು ಒಂದು ಪಾಯಿಂಟ್ there exists c satisfying that condition. okay, thus 0.2 is lies in the interval 0 to 0.5. ಸಪೋಸ್ ಇಲ್ಲಿ 0 ಅಂತ ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ 0.5 ಅಂತಂದ್ರೆ ಸಪೋಸ್ 0.2 ಅಂದ್ರೆ ಇಲ್ಲೆಲ್ಲೋ ಬರುತ್ತೆ. ಓಕೆ, c is equal to 0.2. therefore write the conclusion. Lagrange mean value theorem is verified. Don't write Lagrange mean value theorem is satisfied like that. okay, you should write Lagrange mean value theorem is verified. okay, last problem. here they are given one inequality. ಕಾಣಿಸ್ತಾ ಇದೆ ಎಲ್ಲರಿಗೂ? ಓಕೆ, ಕೊಟ್ಟಿದ್ದಾರೆ ಒಂದು ಫಂಕ್ಷನ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಟ್ಯಾನ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಎಕ್ಸ್ ಅಂತ. ಅಂಡ್ ಇನ್ನೊಂದೇನೋ ಕಂಡೀಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ ಇಲ್ಲಿ, ವೇರ್ ಅಂತ. ವೇರ್ a 0 less than a less than b means a is a number, it is a positive number, a is a positive number, its value is less than b anta, its value is less than b. okay, see here f of x is tan inverse of x. okay, tan inverse of x is continuous in the closed interval, as you all know that. differentiate ಮಾಡಿ, f dash of x, differentiation of tan inverse of x is ಎಷ್ಟು?
1 over 1 plus x square.
1 over 1 plus x square. whatever the values you give to x, you will get the positive quantity. this one, ನೀವು x ಗೆ ಯಾವುದೇ ವ್ಯಾಲ್ಯೂ ಕೊಡಿ, x square ಇರೋದ್ರಿಂದ 1 divided by 1 plus x square is a positive quantity. okay, f dash of x exists in this interval. okay, f dash of x exists in the interval a comma b. in the open interval a comma b means it is differentiable anta. okay, hence f of x is differentiable. okay, next condition. if any function satisfying these two conditions, that means f is continuity and second condition is differentiability in the open interval, according to Lagrange mean value theorem, there exists one point c lies in the interval ab satisfying this condition. f dash of c is equal to f of b minus f of a divided by b minus a. okay, see here ಇಲ್ಲಿ c ಅನ್ನೋದೊಂದು ಪಾಯಿಂಟ್ ಇದೆ. ಎಲ್ಲಿದೆ ಆ ಸಿ ಪಾಯಿಂಟ್? ಇನ್ ದಿ ಇಂಟರ್ವಲ್ ಎ ಬಿ ಇದೆ. ಓಕೆ, ಎ ಈಸ್ ಗ್ರೇಟರ್ ದೆನ್ 0 ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಓಕೆ, ದಟ್ ಮೀನ್ಸ್ ಈ ಇಂಟರ್ವಲ್ ಪಾಸಿಟಿವ್. ಓಕೆ, here this c lies between the open interval a means this c lies between a and b. ಫಸ್ಟ್ ಇವೆರಡು ನೋಡಿ, a is less than b ಅನ್ನೋದು ನೋಡಿ. a is less than b ಅಂದ್ರೂ ಒಂದೇ, c is greater than a ಅಂದ್ರೂ ಒಂದೇ, both are same. squaring on both sides, c square is greater than a square. will you agree? c is greater than a means c square is also greater than a square, isn't it? are you following?
Yes, sir.
okay, ಎರಡು ಕಡೆನೂ ಒಂದನ್ನ ಆಡ್ ಮಾಡಿ, ಎರಡು ಕಡೆನೂ ಒಂದನ್ನ ಆಡ್ ಮಾಡಿ. ಓಕೆ, ಈಗ ಸಪೋಸ್ 2 ಈಸ್ ಗ್ರೇಟರ್ ದೆನ್ 1, ಒಪ್ಕೊಳ್ತೀರಾ? 2 ಈಸ್ ಗ್ರೇಟರ್ ದೆನ್ 1. ಓಕೆ, 1/2 ಈಸ್ ಲೆಸ್ ದೆನ್ 1. ಇಸ್ ಇಟ್ ಓಕೆ? ನೀವು ಅದನ್ನ ಇದ್ರಲ್ಲಿ ರೆಸಿಪ್ರೋಕಲ್ ತಗೊಂಡ್ರೆ ನಿಮಗೆ ಅಲ್ಲಿ ಇನ್ಇಕ್ವಾಲಿಟಿ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಅಲ್ಲಿ ಗ್ರೇಟರ್ ದೆನ್ ಇರೋದು ಇಲ್ಲಿ ಲೆಸ್ ದೆನ್ ಆಗುತ್ತೆ. ಅದೇ ತರ ಇಲ್ಲಿ 1 + c² is there, 1 + c² is greater than 1 + a². If you taking reciprocal, you will get the inequality. ಬೇರೆ ಇದು ಚೇಂಜ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಗ್ರೇಟರ್ ದೆನ್ ಇರೋದು ಇಲ್ಲಿ ಲೆಸ್ ದೆನ್ ಆಗುತ್ತೆ. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಓಕೆ, ನಿಮಗೆ ಈ ಇನ್ಇಕ್ವಾಲಿಟಿ ಬರುತ್ತೆ. ಈಗ ನಾವು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದು ಯಾವುದು? ಇಫ್ t is lies in the interval a to b, ಇದನ್ನ ಮಾತ್ರ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದು. a is less than c ಇದನ್ನ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಒನ್ ಏನಿದೆ? ನೆಕ್ಸ್ಟ್ ಒನ್ ಏನ್ ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕು? c is less than b ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕು. c is less than b ಅಂತಂದ್ರು ಒಂದೇ, b is greater than c ಅಂದ್ರು ಒಂದೇ. ಬೋತ್ ಆರ್ ಸೇಮ್. c is less than b ಅಂತಂದ್ರು ಒಂದೇ. ಓಕೆ, c is less than b. Squaring on both sides, c² is less than b². Adding 1 on both sides, you will get this one. Okay, next taking reciprocal, you will get this inequality. Okay, now 1/1 + c² is less than this value. From these two inequalities, we can write like this. Is it clear? Now 1/1 + c² ಅಂದ್ರೆ ಏನು? 1/1 + c² ಅಂದ್ರೆ ಇಲ್ಲೆಲ್ಲೋ ಬರ್ದಿದೀವಲ್ಲ, ಇಲ್ಲಿ 1/1 + c² ಅಂದ್ರೆ tan inverse of b minus tan inverse of a divided by b minus a. Substitute this value here. That's all. Next step, multiplying both sides, multiplying this inequality by b minus a. b minus a ಇಂದ multiply ಮಾಡಿ. Then you will get this inequality, b minus a divided by 1 + b². ಇಲ್ಲಿ b minus a ಇಂದ multiply ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. b minus a in the numerator, b minus a in the denominator. You will get tan inverse of b minus tan inverse of a is less than b minus a divided by 1 + a². This completes the proof of this theorem. Okay, you try this problem at your home. Lagrange, verify Lagrange mean value theorem for the function, and in the interval 0 to 4, you will get two roots and check whether it is really lies in the interval 0 to 4 or not. Next problem, verify Lagrange mean value theorem for the function f of x is log x in the interval 1 and e. Okay, answer is c is equal to e minus 1. E minus 1 is existing in the interval 1 and e. Okay.